So today I want to talk to you guys about electrical safety. The service panel is your foundation of your electrical system. Older service panels such as Zinsco and Federal Pacific panels have a design flaw in which small arcing causes the breaker to fuse in the on position, transforming it into a conductor instead of an overcurrent device. In an overload condition, the breaker will not trip, causing a fire. Multi-main breakers can lose connection on one phase, causing half of the 120 volt circuits in your house and all of the 240 volt circuits in your house to lose power. That's a common thing I see happen with the old Zinsco panels. This panel right here in this picture is a Federal Pacific panel, and these ones, when you throw the breakers, you see sparks come out of them. If you see a panel like this in anyone's house, feel free to give us a call for an estimate. They're dangerous panels. This is the Zinsco panel that I was talking about, referring to. These are the ones where oftentimes one of the pickups on the breakers actually loses its tension, and you'll lose half of the panel basically on the main breaker. So working space is an important safety concern. All panels require a 30-inch wide, 36-inch deep, and 6.5-inch high working space. Sometimes greater depending on the working environment. When you get into industrial situations where you've got either grounded parts or live parts behind you, they sometimes get greater. But for houses, that's a pretty general rule of thumb. And a lot of times you find panels in spaces that are not safe. Many times I find subpanels in closets, which are a safety concern for more than one reason. Number one, you don't want a panel in a room filled with flammable material. And secondly, there's generally not proper working space in a closet. The reason for working space is that if a person were to get electrocuted while working on a panel, they need to be able to fall away from the panel. When you get electrocuted, your muscles contract. Combine that with not enough room, and you could have a catastrophic result. Proper identification and labeling. Many houses that we work on either have no labeling or incorrect identification. It is important for the homeowner to know how to control power throughout their house, and at a minimum, where the main disconnect is in case of a fire. Many old houses that we have worked on have no main disconnect and no labeling, leaving the homeowner helpless in an emergency. This is a good example. Sorry, the picture is so small, but improper working space over a sink. So there's many safety concerns in this situation. Because if you were to reach into the sink at the same time that you were, touching the panel, you could get cooked, basically. This is another example of a very unsafe working environment and panel location over a shower. Many houses in Sonoma County have been through more than one remodel without proper investment into the electrical system, specifically the lighting. To code, the first switch as you enter a room should illuminate the space that you're entering to prevent anyone from falling in the dark looking for a light switch. Additionally, if the room has more than one entrance or egress, multiple switches should be installed to allow safe control of the lighting. Outlets wear out over time. Regularly used outlets wear out more frequently. Some examples of outlets that we see more use are in the kitchen, bedroom, and living room outlets. Outlets that are not properly attached to their box can cause arcing, which is a fire hazard, and potentially an electrocution danger. Outlets that drop plugs can also cause arcing, as well as electrocution. If anything, the plug's hanging out, if anything touches both the exposed prongs, you get electrocuted. Replacement outlets have a tamper-resistant feature, preventing anyone from shoving paper clips or similar items into the outlet. Small children. It's interesting, a lot of times I come to houses and they've got some tamper-resistant outlets and they've still got the little plastic things shoved in there to prevent their kids from shoving things. I'm gonna have to explain to them, I'm like, these outlets you have actually already do what you're trying to do, basically. Or they have no tamper-resistant protection and we replace the outlets so that their kids are safe. Grounding and bonding are established at the service panel. Grounding protects sensitive electronics from overvoltage, and bonding protects people from electrocution. Grounding is established by way of an electrode installed into the earth and provides a path to discharge overvoltage from the utility company in case of a surge. I still recommend surge protectors for sensitive electronics. Bonding creates an effective ground fault through your electrical system. This is established in every metal component or device of your electrical system, as well as the water and gas pipes. In many older homes, one or more of these components is missing, and in some cases all. Switches and receptacles are also points in the electrical system, and need replacement every 10 to 20 years. This gives us a chance to properly bond the endpoint of interaction with people. We had a customer that had an old metal handled vacuum plugged into an improperly bonded receptacle. When they reached to turn the light on, or when they reached to turn on the light in the room that they were entering, they touched the metal screw on the properly bonded switch cover and got dropped to the ground from the shock. If this switch were properly bonded, the fault would have cleared, tripping the breaker, making it safe. So it is very important to establish proper bonding. The current, they were plugged into an outlet, and basically the ground prong on that outlet was live from a fault inside of the outlet. On the switch was properly bonded, and that screw is attached to the yoke of the device, which is bonded properly. When they touched the switch and hit the screw with their finger, they had a path between their chest from the source, basically, because the body of the vacuum had 120 volts flowing across it. The screw basically provides a path back to the source for voltage to flow, basically. So if that were properly bonded, when that fault occurred in the switch, it would have tripped the breaker. But a lot of times I come to houses and they have no bonding on the switches. GFCI protection is a term to describe an extremely sensitive overcurrent device. The standard breakers in your panel protect the electrical system from causing a fire in an overload condition, but they do not protect people from electrocution. A GFCI is designed to trip at 4 to 5 milliamps in 1/10 of a second, which supposedly is the maximum current that a toddler could release the muscles in their hand if they knew what was happening. 10 milliamps for an adult woman and 15 milliamps for an adult man. Anywhere that you are likely to have an interaction between electricity and water, you should have GFCI protection. In your kitchens, bathrooms, laundry room, garage, outdoor receptacles, all of those should be GFI protected. Smoke and CO detectors must be installed on every floor of a residence, in each bedroom, and one per hallway serving bedrooms. One carbon monoxide sensor per floor on a building. It is important to properly locate your smoke detectors. You want to place them away from your bathrooms and kitchens due to nuisance tripping from cooking smoke and shower steam. Not only can we make your house safer, but many times people only do these repairs when they are selling their house. The value carries through to the next person that purchases your house. Often customers express frustration when they are fixing the house up for the next person when they could have done these repairs when they first moved in. Who do you know that has recently purchased or owns their home? We would love to meet them and assess their electrical safety. Thank you, everyone. Does anyone have any questions?
Brandon,
Yeah.
Just a fast one. Insurance companies are making my clients change out their Federal Pacific breaker boxes. What happened to Federal Pacific? Why are they getting pulled out of the buildings and replaced?
So a lot of those older panels were companies that were started right around, the Great Depression and the end of World War II, and they went out of business, but they were in so many houses that other companies took up manufacture of their products, basically. So they had different companies producing their breakers and different things like that. And a lot of these companies, I guess the enforcement just wasn't what it is today. Basically, they would just go ahead and just stamp on their products that they were listed, and they'd gone through no listing process whatsoever. So there was a lot of like black market. I mean, they were sold legally, but basically they were items that so technically a breaker is supposed to trip at 135% of its rating over a period of time. A lot of these breakers brand new from the factory don't trip at over 200% of their rating when they were sold. So That's the problem. They didn't work properly out of the box. So, yeah. And people's electrical demand was a lot less back then. So it didn't really come up as much, but we've had many a time where we replace an old Zinsco panel and then the customer's got like tenants or whatever, and they're like, hey, our breakers are tripping all the time now. And I'm like, well, it's a good thing we changed the panel. And they're like, why? And I'm like, well, because that means that the wires were being overloaded in the past. If they're tripping now and they were never tripping in the past, then that was a potential fire every time that they weren't tripping, basically. So
Okay,
hopefully that answered your question, David.
yep, it did.
Jolene?
Well, David got me thinking about something else and wondering why you're learning about what panels your clients have. So that's just interesting. It's cool. But yeah, Brandon is terrific. He's always helping my clients, but I really don't want to learn how much amperage I can handle. So any other quick questions for Brandon? Okay, thank you, Brandon.
Thank you, everyone.
Karen has one.
Brandon, do you go to Kelseyville?